So first one is the fundamental frequency, second diagram give the third harmonic, and third diagram give the fifth harmonic. Derivation proof clearly I am going to give to you. Okay. Hello everyone, I am your Kiran Kumar from the Nature of Physics. Today topic is closed organ pipe. Step by step neat diagram I am going to explain. Please do like and subscribe our channel Nature of Physics, including numericals. Okay students, see. Student, open organ pipe video link I will provide in the description. Okay. First basics about the closed organ pipe. Organ pipe is a cylindrical tube with air column, so filled with air column, student. Okay, and the pipe with both ends are open is called open organ pipe. Here the pipe with one end is open and another end is closed is called closed organ pipe. Closed organ pipe, nothing but one end is open and other end is closed, and always open ends antinodes form. See, antinode, antinode, and closed end node will be formed, student. And always longitudinal stationary waves will be formed in the closed organ pipe and also open organ pipe. Okay, in stretched string transfer stationary waves form, but in the pipes longitudinal stationary waves will form. Longitudinal stationary waves in which node represent the zero displacement, student, from the mean position. Antinode represent the maximum displacement from the mean position of the pipe, student. And next one, node and antinode. After that we will discuss the fundamental frequency. The fundamental frequency, the minimum frequency with which stationary waveform is called fundamental frequency, student. Minimum frequency is off loop only here for the first diagram. And next one, here harmonics and overtones are there, student. Harmonics nothing but overtones also representing the alternate name of the frequency, student. Harmonics nothing but the frequencies which are integral multiply the fundamental frequency is called harmonics. The frequencies which are integral multiply the fundamental frequency are called, what are that, student? Harmonics. Then the higher harmonics are called overtones. Step by step I am going to explain with respect to diagram, student. So length of the pipe must be same, first diagram, second diagram and third diagram. So this is first diagram, second and third diagram. See, student, considering a closed organ pipe and taken a tuning fork and vibrated by the rubber hammer kept at the open end, resonance phenomena takes place, student, in the open pipe and also as well as closed organ pipes. Okay, so in the first one, in the closed organ pipe, the length is equal to wavelength is only half of the loop form. The distance between the antinode and node give the lambda 1 divided by 4. Simply lambda by 4. According to the diagram I am writing lambda 1 divided by 4. Okay, student, and the length of the pipe I am writing before that. The fundamental frequency or first harmonic of closed pipe will have node at the closed end, antinode at the open end. The distance between the node and antinode is lambda divided by 4, that we are considering lambda 1 divided by 4. See, student, the length of the pipe is equal to wavelength, so that L which is equal to lambda 1 divided by 4. Okay, student, and then continuation wavelength is writing based on the length of the closed pipe, student. Wavelength lambda 1 cross multiplication lambda 1 which is equal to 4L, and then frequency writing frequency basic formula, that is N is equal to V divided by lambda, so that this is a closed organ pipe. So writing NC which is equal to V divided by wavelength we are considering lambda 1. Okay, student, and then continuation NC which is equal to V divided by lambda 1 is equal to 4L we got. Okay, this is writing as equation number 1. So V represent velocity of sound, that is 333 meter per second is remains constant. Okay, here one thing you have to notice. So NC represent the fundamental frequency or first harmonic of the closed organ pipe. Okay, so that is fundamental or fundamental frequency or first harmonic of closed organ pipe. Okay student, and then second diagram, this is representing third harmonic or first overtone. Why third harmonic? There is a ratio in the open pipe of the harmonics is 1:2:3, but in the closed organ pipe I'm going to get 1:3:5, so that in the second diagram I'm going to get the third harmonic. Okay, wait and see proof. And of a closed pipe will have the two antinodes and two nodes student. See, one node is there and next to diagram two nodes. Here one antinode is there, next to two antinode, one is increasing. Okay, so that two nodes and two antinodes. Length of the pipe is L representing, tell me student, L representing, which is equal to lambda 3/4 plus lambda 3 divided by 2. Okay student, so length which is equal to 2 multiplying and dividing, that is okay 3 lambda 3 divided by 4 student. Now wavelength lambda 3, from the above equation lambda 3 is equal to 4L divided by 3. Okay, and next one I'm going to write the frequency N1 writing, that is the first overtone. So basic formula here only writing N1 is equal to V divided by lambda 3 student. Okay, third harmonic, so considering wavelength also lambda 3 student. Okay, and lambda 3 value replacing from the above equation, so N1 which is equal to V divided by lambda 3 is 4L by 3. From this I'm going to get N1 is equal to 3 into V divided by 4L, so that from the fundamental frequency of the closed organ pipe, okay, so which is NC which is equal to V divided by 4L is replacing now N1 which is equal to 3 into V by 4L is equal to NC. NC we got V by 4L, so V by 4L is writing as NC. This is I can write as equation number 2. Equation 2 represent what is that student? Okay, that is third harmonic, or tell me student, first overtone, okay, of closed pipe writing. See student, next third derivation I'm going to explain based on the third diagram. See student, for this fifth harmonic or second overtone of a closed pipe derivation I will give to you, that have the 3 antinodes and 3 nodes. Already we are doing sequentially, one node and no antinode is increasing. Okay student, so length of the pipe I am writing here, length of the pipe L, okay, here L writing which is equal to lambda 5/4, fifth harmonic, that's a lambda 5 writing, plus lambda 5/2 plus lambda 5 divided by 2 student. So that is L which is equal to 2 multiplied and divided, that is 5 lambda 5 divided by 4. I got length student. Okay, and after that wavelength replacing, wavelength writing lambda 5 student, I did mistake, lambda 5 which is equal to 4L divided by 5. Next to frequency writing here, the frequency formula, basic formula N is equal V divided by lambda. So in this N, second overtone we are getting, so second I am writing second overtone, C student, and E is equal to V divided by lambda 5 student. Lambda 5 value is replacing, that is N2 which is equal to V divided by 4L by 5. Okay, so that continuation step N2 which is equal to 5 into V divided by 4L. Okay student, so that N2 which is equal to 5 into V by 4L. V by 4L is equal, what is the value student? V by 4L is equal to how much? Nc is the fundamental frequency of closed organ pipe, that is Nc is equation number 3 student. So notice that here Nc which is equal to V divided by 4L writing, already we did, and this equation 3 represent, what is that student? Fifth harmonic. Okay, or not and, or what is that? Second overtone, okay, of closed organ pipe. Okay student, this is clear information about the closed organ pipe. End correction video link I will provide here in the description. So problems we have based on the open pipe and also closed pipe student. Okay, remember. So first problem, the fundamental frequency of a closed organ pipe, okay, is equal to, okay, fundamental frequency that is of a closed organ pipe is equal to first overtone frequency of a open organ pipe. So that I will write, so fundamental frequency, okay, of closed organ pipe is equal to, what is that student? First overtone of open pipe. See student, open pipe. So that the equation fundamental frequency of closed organ pipe, okay, mu or n, anything we can write student. Here mu I am writing, in the derivation n taken, anything same only. Fundamental frequency of closed organ pipe which is equal to first overtone. According to the question given, fundamental frequency of closed organ pipe, C represent closed organ pipe, is equal to first overtone of open pipe. O represent open pipe, first represent overtone student. And once again I will read the question. The fundamental frequency of closed organ pipe is equal to the first overtone frequency of a open organ pipe, okay, of a open organ pipe. If the length of the open pipe length is equal to how much given student? That is 60 centimeter. Then the length of the closed pipe LC is asking student. Okay, then continuation, the fundamental frequency of closed pipe V divided by 4LC student, that is first overtone of open pipe, that is second harmonic 2 into V divided by 2L. Open organ pipe length is L0. 2 is get cancel, VV also get cancel, and then continuation 1 divided by 4 into length of the closed pipe. We have to find LC which is equal to 1 divided by length of the open pipe, rewriting, okay, L0 which is equal to 4LC student. LC is asking, LC which is equal to L0 divided by 4. So that continuation step, LC which is equal to L0 is equal to 60 centimeter given divided by 4. So that this is equal to length of the closed organ pipe is 15 centimeter is the answer for the given question. Okay, and next question we will discuss. See student, second question. In a closed organ pipe, the frequency of fundamental node is 30 Hz is given. See student, what is the pipe is given there? So closed pipe. Okay, what is the fundamental frequency? Nc which is equal to V divided by 4L. Notice that. Okay, so first diagram is there, second diagram is there. So first, in a closed organ pipe, the frequency of fundamental note NC is equal to 30 given, and velocity of the sound is 330 given, 330 meter per second, divided by 4 L1, first one L1 considering, student. Okay, and 0 0 cancel, and once 11 times, so I got here continuation step, that is L1 which is equal to 11 divided by 4. See student, here I got 1 which is equal to 11 divided by 4 L1, 11 divided by 4 L1. L1 is equal to, what is that student there? 11 divided by 4 is the first equation. Step by step I am going to explain, and then continuation question. Okay, so that the fundamental frequency is increased. How much, student? Next one is NC dash, which is equal to given 110. If the organ pipe has cross sectional area 2 centimeter square, the amount of water poured into the organ tube, that is closed organ tube, is in grams, is asking in the question. See student, first one is a closed organ pipe. Okay, and next a certain amount of water is now poured into the organ tube, so that water is filling, student. Whenever water is filling, the level of water is considering at the bottom is H, and in the second condition also we are getting fundamental frequency only, student. So fundamental frequency is given, closed organ pipe NC dash is equal to 100 hertz. So first one NC is given how much, student? That is 30 hertz. Okay, already we did here first one. And second one I am going to write NC dash, which is equal to V divided by 4 L2, student. L1 L2 clearly represented, now L2. Okay, see student, for this here wavelength is lambda, taking here wavelength is lambda dash, but no need to discuss about the wavelength in the derivation. Okay, NC dash given 110 hertz, sorry, which is equal to velocity of sound is 330 divided by 4 L2, student. So this is okay one time, and this is 3 times, student. Now L2 is equal to 3 divided by 4. This is equation number 1. Here rewriting 1 is equal to 3 divided by 4 L2 I got. Okay student, and continuation next one here, the difference I am writing here, the difference is L2 minus L1, which is equal to height, student. See there clearly representing the height, which is equal to L2 is equal to L1 minus L2, sorry, what is that? L1 minus L2. So L1 minus L2, so H is equal to L1 is equal to how much we got, student? 11 divided by 4. L2 is equal to 3 divided by 4. So that continuation derivation here, H which is equal to 8 divided by 4, H is equal to I got, okay, 2 meters, that is 200 centimeter. Okay student, and area is equal to given there, area which is equal to 2 centimeter square, centimeter square is given. Okay, so that volume which is equal to area into height of the tube. Okay student, so that volume I am getting, that is area is 2 into height is equal to 200, so that volume I got 400, okay, centimeter cube. And then next step is basic formula, density rho which is equal to mass divided by volume, and mass which is equal to density into volume, student. So M represent here mass. Okay, so rho represent density, density is 1 gram per cc, student, 1 gram per cc, cubic centimeter cube. Okay, so 1 gram per cc. C student. So M, which is equal to density 1, and volume how much we got? 400. So mass is equal to, in the grams we are getting 400 grams is the answer for the given question. Okay student. And next one, yes, next question, a closed organ pipe. So LC, closed organ pipe 150 centimeter, which is equal to 1.5 meter, gives 7 beats. So delta N, which is equal to 7 beats given. Okay, delta N, which is equal to here N1 variation, N2 student. So first I will read the question, then values I will replace. Okay, basic formula, delta N is equal to N1 minus N2, 7 beats per second with an open organ pipe of length. So open organ pipe length is equal to 350 centimeter, which is equal to 3.5 meter. Both are vibrating in the fundamental frequency only student. So fundamental frequency NC is equal to V divided by 4LC, and here fundamental frequency N0, which is equal to V divided by 2 L0. Okay student, so that continuation. Next, the velocity of the sound, V is asking in the question, velocity of the sound. Okay, try to understand here. Once again reading, a closed organ pipe length given, okay, 150 centimeter along, gives 7 beats also written, with an open organ pipe of length given. Okay, both vibrating in the fundamental mode, both are in fundamental mode written. Then the velocity of sound is asking, so that I am writing NC and N0 student. Okay, delta N, which is equal to NC value is equal to V divided by 4LC minus N0 value is V divided by 2L0 student. So that continuation step now, that is delta N is equal to how much given in the question? 7 beats, 7 which is equal to, okay, so V common student, V by 2, so that is 1 divided by 2LC minus 1 divided by L0. So 7 which is equal to V divided by 2 into 1 divided by 2 into LC value, that is how much student? 1.5. okay, minus L0 value is 3.5. so see continuation, 7 which is equal to V divided by 2 into 1 by 3 minus 1 by 3.5. So 7 is equal to V divided by 2 into 3.5 minus 3 divided by 3 into 3.5. So that 14V into numerator is 0.5 divided by 3 into 3.5. So after solving we will get velocity V, which is equal to 294 meter per second is the answer for the given question. Okay student, and next last problem, fourth problem I am going to explain. See, clearly given. So what is the condition is given? So there is a beat frequency between the closed pipe and open pipe, that is delta N is equal 7 beats given between the closed pipe and open. Both lengths are given, so velocity of sound is asking, that is 294 meter per second I got according to the question. Okay, and in this pipe, a closed and open organ pipes have same length. Closed organ pipe and open organ pipe have the same length is L. If the ratio of their frequencies in the 7th overtones given, okay na? So that first closed pipe, that is NC of 7th overtone divided by n open pipe of what is that 7th overtone, which is given a minus 1 divided by a. Student, in the question A is asking, see student, for this the basic formula I am going to write n open pipe, which is P, which is equal to P plus 1 into V divided by 2L O. Student, and n closed pipe Pth overtone, which is equal to 2P plus 1 harmonic V divided by 4L C. Student, length is commonly given here, and then replacing the values in the above equation. Here P is, in the both questions P is given as 7. Student, so replacing that, C student, that is NC. Okay, P value is 7th overtone divided by NO of 7th overtone, which is equal to 2 into P is equal to 7 plus 1, okay, into V divided by 4L common length divided by, tell me student, P value is 7 plus 1, V divided by 2L. V by L is get cancelled 2 once, so this is 2 times is get cancelled, there is 1 by 2. Student, and then continuation derivation, this is C student, this is NC by N0 7th one is equal to A minus 1 divided by A is given, which is equal to this value numerator 7 2s are 14 plus 1. Okay, here the value is 1 by 2 is there. After calculation I got this student, notice that, divided by, so this is 7 plus 1 is 8. Student, okay, A minus 1 divided by A, which is equal to, this is 15 divided by 16. Student, cross multiplication, 16 minus 16, 16A minus 16 is equal to 15A. Student, okay, rearranging the equation, that is 16 minus 15 is 1 only, A which is equal to 16 is the answer for the given question. Please do like and subscribe our channel Nature of Physics for more videos.